So, hi, mathematicians. So, this is all about pricing Brad's baseballs, page 15. We're going to be going over this on Tuesday at 11 o'clock. If you'd like, if the live Zoom is more your style, this is the recorded version to kind of give you some clues and hints about how we should fill this page out. Now, this is going right along with our ratio tables, expressions, and equations. So we're trying to solve these big multiplication problems by using ratio tables. So this says Brad is taking inventory of the balls in the storeroom and deciding how to price them to sell. Solve each problem and write an expression or an equation and to represent it. There is a box of 100 miscellaneous balls that Brad wants to sell. So he has 100 of them, and it's a box. So it says, what are one or two possible sets of dimensions for the box? So it's a rectangular prism, and remember, when we are looking for volume or dimensions, we use length times width, and we put that in a parentheses. And then boxes, they're not only the area on the bottom, but they go up as well. So we have length times width times height, kind of like my Kleenex box here. We have length on the bottom, length on the bottom, width on the bottom, and then height going up. So if it was a box like this, length times width times height. These three numbers all have to equal 100. So what are three combinations of numbers when we multiply them together will equal 100? Well, I can give you one example, and then I'm going to let you do the other one. My example would be, well, we can have 25 times 2, and I put that in parentheses because that's what I'm doing first. So 25 times 2 is 50. And then what do I multiply 50 by to get to 100? So if 25 times 2 is 50, 50 times what? If I double 50, I get 100. Ooh, double, so I just need to double that. Gives me 100. 50 times 2 is 100. So can you think of another set of three numbers when we multiply them together will give me 100? And please don't use 25, 2, and 2. Like you could do 2 times 2, which is 4 times 50. But I want you to see if you can think of another set of numbers you can do to equal 100. So then we have, what is the total price for the box of balls if Brad charges $20 per ball? Okay, so my expression is 100 times 20. There's several ways that we could solve this problem. You could just you could say, what's 100 times 20? Well, 100 times 2 is 200, right? 100 times 2. But we are not multiplying by 2, we're multiplying by 20. So I have 100 times 2, which is 200. I have my 2 zeros here, but I have an extra 0 that I need to add to the end. So we could stop there and just say 2,000. Or you could say 100 times 10 plus 100 times 10, because we're splitting the 20 up into two tens. Or you could do a ratio table real quick. I'm going to show you that just so you have that. So we have our miscellaneous balls that he has in his warehouse. Then we have the cost of those. So we always start with a unit rate. So one ball costs $20. That's what it says right here. One ball costs $20. I need to get to 100. So I need to get this to 100 balls. So I'm going to start with something that I know. So I always like to start with 10. So I'm going to go jump up to 10 balls. Whatever I do to the top, I have to do the bottom when I'm multiplying. So I have to multiply my 20 by my 10. 1 times 10 is 10. 20 times 10 is 200, because 2 times 1 is 2. And I have 2 zeros here. Multiplying that by 10. All right, so now I'm at 10. I can get from 10 to 100 if I multiply this 10 by 10. So I'm going up by multiples of 10. 1 times 10 is 10. 10 times 10 is 100. Okay? So I'm going to do the same thing to the bottom and multiply the bottom by 10. So 10 times 10 is 100. 200 times 10 is let's see, 2 times 1 is 2, and I have 1, 2, 3 zeros. 2,000. So 100 times 20 is 2,000, and I got that as well here. But what if he charges $19 per ball? Ooh, okay. Well, I could do the same thing. So my expression is 100 times 19, okay? And you might say, well, I know 1 times 19 is 19, Mr. Mac. You are correct. And I have 2 zeros here. So that's one option. You could also do the ratio table and get it through the same thing we did with the 20, except for now you're dealing with 19 instead of $20. So you'd set it up the same way, but instead of the cost of 19, it would be, instead of 20, it would be 19. That's a 9, not a 4. So we'd have the same ratio on the top, and the balls on the top, and the cost on the bottom. And then you would do the exact same thing, but you would go up by 19s instead of 20s. And then if you charge 21 per ball, it's the same thing. He still has 100, but now he's charging 21, okay? So can you solve that problem as well? So then we're going to go down to number 2. So number 2 is a little trickier because now Brad notices that there's only 99 balls in the box instead of 100. So we're taking 1 ball away, okay? So what's the total price if he wants to charge $20 per ball? So we still have, so the expression is 99 times 20, right? We have 99 balls and we're multiplying that by 20. So there's several ways that you could solve this. I'm sure that you're thinking about it right now. So we could do a ratio table, which is what I love, as you all know. So we always start with our unit rate of 1. And this ratio is still $20. So right now, 1 ball costs $20. I want to get to 99 balls. So I remember from up here, when I did my ratio table of 20, when I got to 100, it cost $2,000. So what we can do is jump right to 100. And I know that costs $2,000, but I need 99, not 100. So I need to take 1 baseball away from 100. That gives me 99, right? But I'm not going to take 1 away. I need to write my times in here. I'm not going to take 1 away from 2,000. That's not how much a baseball costs, is it? How much does a baseball cost? Oh, it costs $20. So my ratio of taking 1 baseball away, now I have 99 baseballs, taking 1 away is actually taking $20 away. So I need to subtract 2,000 minus 20. So what is 2,000 minus 20? You could also say 100. So what I just told you there was 100 times 20, which is what we did here. 100 times 20 is 2,000. And then you can subtract a set of 20. So what that's doing is taking one set of 20 away, which is what I did here, to get to my 99. A lot of different ways you can solve for 99 times 27. What if he charges $19 per ball? Well, it's the same strategy. You can do the ratio table again. And if you did your ratio table up here to get to 100, you're just taking $19 away from that 100, from the 100. So if you already know that 100 baseballs cost you $1,900, well, then you're just going to take $19 away from that. So this expression is 99 times 19. And then I want you to solve that. And then what if he charges $21 per ball? Well, if you did the same thing up here, if you did 100, you're going to take 21 away from that answer. So this expression is 99 times 21. You can use a ratio table. I want to see your thoughts and I want you to talk about it. So when you submit this assignment, everyone's going to submit this assignment. You're not going to take a picture or anything. Well, you can. That's an option. You can take a picture, but I want you to explain with the video on how you solved either number 1, all of these, or number 2, A, B, and C. Okay, so pick one of these questions, but you have to do A, B, C, or D. Okay, so that's how you solve that, and I want you to explain it to me further. Okay, all right. I hope that helps. Good luck, mathematicians.